For our next speaker, we're thrilled to welcome Marc Segura. Marc is the Group Senior Vice President and Managing Director of Consumer Segments and Service Robotics at ABB. Marc has been with ABB for 23 years, serving in various management roles based out of Spain. He now manages the delivery of robotic solutions for the entire life cycles of consumer goods and healthcare services to sustainably provide the goods and services that people need. Marc joins Brad Porter, Scale AI's CTO, for a fireside chat. Brad, take it away.
Welcome, everyone. I'm Brad Porter. I'm Scale CTO, and I'm incredibly excited to have the opportunity to host this conversation with Marc Segura from ABB. Marc and I had the chance to cross paths a bit when I was working on robotics at Amazon, and it's great to be connected again. Marc, I think I'll let you do the honors of introducing yourself, because I would love to hear more about your background.
Yeah, thanks, Brad, and thanks, Scale. It's an enormous pleasure for me to be here and to represent ABB as well. So I'm Marc Segura. I'm the Global Managing Director of Consumer Segments and Service Robotics in ABB. I've been 23 years in the company, and I think I can say I've done most of the jobs you can do in robotics. So I'm really passionate of technology, of solving problems with the customers. So I hope I can contribute in this chat to share a little bit of the vision about robotics in general, especially how AI is really changing the game here.
Oh, that's awesome. Actually, I want to start and learn a little bit more about your background. What was your path to robotics and to ABB?
Yeah, I think that was kind of destiny, because I'm from Barcelona in Spain. And I studied engineering, electromechanical engineering, and then a master's degree as well in robotics. But while I was growing up, I had a cousin of my mother was working at the Nissan factory. He was working in the press shop. And while I was studying, I said, okay, you need to choose one topic, make a little work on it. I said, okay, maybe my cousin can bring me in the car factory. I heard it's amazing. There's full of robots. And I went in. And the first thing I saw in my face was some ABB robots in the press shop. Okay, I was about 15 years old, and that really shocked me. That was huge machines, big things, moving fast, and I could feel the bits and bytes flowing through to make that animated. So that really triggered my interest. So that's why I studied. And at the end of my degree, I just sent one resume that was to ABB. And I was called, okay, that was June, and the 1st of July, I was starting in 98 in ABB, and the induction process was pretty sophisticated. I was given a 4 days training on robots, and I was given a flight ticket to a Renault factory. And at that time, our robots were orange, so our robots are the orange ones. So that started, and I was 3 years doing installation and projects in Ford in Australia, in France, in Renault, doing PLC, PC, robot programming, and the mechanical, electrical installation, the site management. And then I ended up at General Motors in Mexico, 1 year there, building the factory in Silao with a lot of American companies, Allen Bradley and others there. Was a great learning. And that was really, great times to really learn in the field what this is all about. And then from that, I took into project management, operations management, and was running the whole business of ABB in Spain for automation for 3-4 years. And then when I was running a 300 million business with 400 people, I was asked by the global robotics boss, hey, you want to jump into a startup? We're looking beyond robots in manufacturing. We're looking at logistics, healthcare, service robotics. And I said, yes, what's the deal? He said, we have 10 people in UK. You want to take it? And I said, yes. So that was 4 years ago. And now our business line, consumer segments, is above the 300 millions. We have done some very nice acquisitions of logistics in Belgium recently, the mobile robotics of Asti. And it's not only our merit and my team's merit. It's really, we are in a change of paradigm in the market. Amazon is, and you, Brad, personally are pretty much guilty about this change in the world, but very much the supply chain and the value chain in from manufacturing to distribution to commerce is changing, has fused, and this is now we are on a mission here today.
the yeah, incredible progress. I mean, I think we often think about the combination of robotics and AI as being a big unlock for a robotics revolution. But in many ways, robotics has been transforming industries for a long time, right? And so, what have been some of the kind of game changers you've seen in your 23 year career in the way robotics are used and deployed?
It's really changing a lot. So that's why I always say that robotics, it's for all the progress we've done, it's in its infancy, because robotic was born in automotive and it grew up in automotive in the 80s to basically take on repetitive and dull tasks like spot welding and painting, tasks that were unsafe, that required a higher degree of quality and repetitiveness. So that's why robots were massively growing in the body shops and in the paint shops and in the press shops. That shaped the robotics of the 80s and the 90s, clearly. Because automotives have certain needs and they are extremely good at certain things. So the focus on the technology development was driving robustness, repeatability, reliability of the product, as well as cost down. There was tremendous innovation to bring the cost down, so automotive was driving that. But that evolved, but then in the 2000s, because also one thing from robotics is, I mean, it can take any technology development. That's also the beauty of robotics. We can write any exponential. So when the 2000s started, there was an expansion from a segment perspective. We started to do more in food and beverage, in pick, pack, palletize. Later on came the boom of electronics. From 2008, 2009, we started to install lots of robots in electronics. So this was this manufacturing expansion within different segments. And just a data point, which is very, very relevant. If you took the IFR, the International Federation of Robotics numbers, the decade of the first decade of 2000 was stagnant. The number of robots sold per year was steady around 100,000. So you would wonder we were doing a bad job altogether in robotics. But after the 2009 crisis, and until in one decade, it has multiplied by 4. So we are above the 400, really close to the 500,000 robots, industrial robots sold per year. That's only industrial. It does not account for service robots. So robots were still in this manufacturing, working in a control environment. It's manufacturing, it's jig-based. So robots had, I would say, not a lot of intelligence, okay? If you look at it from a modern perspective, they were doing repetitive tasks. So they needed a control environment, they needed a jig, they needed a predictability. Everything is designed for the robot automation thinking. And that worked very well and still working very well, expanding in industries, but there was a natural constraint. How do you get into unstructured environments? How do you get into things where things are unpredictable and robots need to be adaptive? And that's the latest development where cloud computing, AI, the development of batteries for mobile robotics, you name all these developments, the sensors developed by iPhones and so on, all this is flowing into the robot as technology breaks. So we are now ready, and we'll talk about what AI is bringing, to solve more problems, to expand robotics really, really mainstream in any kind of segment. We're seeing the growth of robotics in healthcare, in logistics, in restaurants. And this will be a total game going forward.
Yeah, you alluded to the differences when you move beyond manufacturing, but I wonder if you can color those in a little bit more for our audience as you move into logistics and others. Where do the problems become stickier?
Yeah, in a manufacturing environment where robots are taking tasks, they are taking repetitive tasks that are also designed for steady conditions. For example, if you need to weld two metal sheet parts, okay? These metal sheet parts will always be the same because you're doing a limited number of cars. Even if it's lots of different cars in one line, it's still a limited and known number. You know up front the parts that are going to come. You're going to have toolings and fixtures to locate them in the exact same position. So then the robot with a few inputs can blindly go and repeat the task. I'm going to apply a welding point here, there, and there. Okay? So there is the conditions, the environment is fixed, is engineered up front, and then it stays forever the same. So robot interaction and robot adaptability is not needed. The robot is kind of blind, okay? But that's solving a lot of problems as long as your environment is like that. Because robots, for example, have been doing machine tending for ages. That was one of. But to load or unload on a machine is a simple operation because you are picking an object and putting it in a concrete place, and then you're taking it from that place and you're dropping it out. But that same problem becomes extremely difficult when you don't know which parts you have to pick, when you have never seen, which is the challenge in, for example, e-commerce. So robots have been doing machine tending for ages, but the environment was that I know that I have 2, 3, 4, 10 different parts. Anyhow, I know them. I have the CAD drawing, and I can make some jigs to locate them, and I know where to put them. So the robot can do that repetitive task. Take the same, abstracting it's the same operation because you're going to pick and place. But instead of having 10 known parts, you have, 1 million different SKUs that are changing every day. You cannot program that. You cannot have the drawings for that. You just need to deal with that new thing every time over and over. And that's something that traditional engineering could not solve until AI came out.
Yeah, pivoting more into AI, give me a little bit your thoughts on how you build up robotic skills. Do you build them up one at a time and compose them, or learn fully integrated skills at once, or is it a combination?
Yeah. First, I think a little bit to agree what skill is. When we think about skill, not even in a robotic environment, we see that as a sequence of actions and decisions. No, I mean that are solving some task. The first thing in robot skills, which I believe, by the way, is a very important concept going forward, and I'll elaborate on that, thinking about cloud-based robotics and so on. We really need to break down these skills into certain smaller skills. For example, if you want, as I alluded, you want to pick something from a box and put it into another box. That could be an order fulfillment process, simple as that in e-commerce. You need to break it down first. Thing is, you need to localize the box. That could be one skill. Then you need to localize the object inside the box, segment it out from the rest. And then you need to decide how to pick it, actually pick it, and then comes the dropping process. So those skills are now becoming, first there are some hard skills that are more related to the motion control of the robot, but then there are other skills that are more related to the application. And what AI is bringing is a great possibility to develop robot skills that are learning over time. And if you really reinforce them by having them located in some kind of a central learning place, could be the cloud, could be the edge, it doesn't matter. Over time, you're going to do a specific skill better and better and better. And then, of course, you can start to relate them and sequence them, again, at the cloud level or at an edge level. So robot skills and eventually a skills net, okay, is something that is very likely in the future as robots are using more AI to become better at a certain skill. The skill could be grasping. The skill could be quality inspecting a welding sim, okay? I'm doing the welding sim. Time could be setting the parameters for painting a car with all the parameters of viscosity, humidity. That only AI can do. That is a specific skill, and that skill will be growing over time if we have the right architecture, which now is possible.
How do you think about, pushing the boundaries of the types of robotic skills that can be built? Is it the framework and architecture, or is it the new techniques or new sensors? Where do you see the greatest innovation?
I think we don't lack any innovation, but I think the bottlenecks for scaling robotics and AI robotics are still pretty old, I would say. It's here we're matching hardware with software, and that's the big difference from AI in pure software. For more that we can scale the software part, there has to be some way to standardize or harmonize the hardware part. Anyhow, you're always hitting the same roadblock, which is you need some hardware ad hoc engineering to scale up or to define any project. And I think here the definition of the robot skills will help a lot, okay? I think if we start to have some ecosystem of skills based on kind of app concept that people can start to reuse, that will and is already creating an ecosystem of the matching and the factors for that, for example. So you can really relate the mechanical part with the software part, and then this real, that's the boring part of it, but Brad, that's really the bottleneck as we're seeing right now, okay? then the innovation we will not be lacking. Why? Because you take machine vision. That is really industrial grade. We can really pick and place almost any object, okay? Now the bottleneck is how we run the last mechatronic part, the end effector piece. If you take advanced navigation, and the autonomous car guys knows more, but that we know, and you know, that in slow speed autonomous robot, we can already navigate quite smart and safe in 3D and do smart things about, for example, understanding the world semantically. So I'm an AMR. I know that if I move towards the person, it's not the same that moving towards a box because I have the semantic understanding. So I think the innovations that are really will enable robotics is everything related to be able to operate on a dynamic environment, okay? That stands for the machine vision and the ability to autonomously grasp objects. And the other big element is the autonomous mobility, to have the ability to robots having different and flexible workflows, okay, in a facility enabled by 3D navigation. And the third one is the quality inspection. The advances of quality inspection thanks to robotics are also very important in industry, because the ultimate vision is that you have embedded quality optimization, meaning that I am performing a process. Take a very analog process, arc welding or painting. You have lots of tuning there. The intensity, the temperature, the humidity. And you have really gurus, experts. A guy that's done that for 25 years is the best, but the only one in the world who can do it. That data, we'll talk about data later, that data now can be used to be understood and to be in real time correcting the process. So autonomous grasping, autonomous navigation, and in-the-loop quality improvement and quality assurance. These are the three big things that AI will change robotics.
Yeah, let's pivot a little bit and talk about data. As you have more of these systems deployed with more and more richer sensors, there's massive amounts of data, right? But you also alluded to other sources of data, the humidity in the room, other things that you might not traditionally think the robot has access to. So there's a lot of untapped data. There's massive amounts of data. How do you think about using that data as an asset, and how do you think about what's possible now as we can process more data?
We're extremely excited about it because for good or bad, our robots or the robots are at the heart of the manufacturing processes and going forward in the distribution process and so on. They are there. They are the witnesses and they are the starrings. So if we give them the sensing of the environment and we use that data on their process and their decision-making process, that can untap a lot of value. Going back to the data, so I was already alluding to it. Quality, okay? Quality is one of the most important things for our customers, of course, when you manufacture. But the reality is that the data is unused, totally unused. When you cannot gather real-time data and use it, you're based on statistical process, and that's the state of the art. We are using samples and statistics, but we are not using the real-time complete data. If we can use that untaped data, the potential is huge. And again, I'll put you two examples that we are already having real projects in the world. Take paint, as I said, any painting process. That's very, very complex from a process standpoint. As I said, you have varying viscosities of the paint. You have different temperatures, humidities. So that is very analog process. Now, how do we really correlate? How do we find out of that data the patterns? Okay, and that's where AI is very strong. How do I look at the patterns? How can I find a hidden model? And how can I use that hidden model to regulate or self-regulate or self-optimize the process? That is one important aspect where data will be used in process. So processes can be paint, can be arc welding, can be many other things. If you go more to other type of data, of course, you go into order fulfillment, and you have these goods-to-person AMRs, and you need to fulfill an order. Of course, using the data from the consumers, which SKUs are bought with which frequency, when, and using AI to better allocate. This is what Amazon pioneered and many people are following right now. You have a more efficient storage and retrieval system. Okay, that's also AI and robotics using data, and I could talk about many more. I mean, what we see also coming, as you said, is putting the human in the loop. Okay, we have the rise of collaborative robots, and we're going to have more and more mixed work in between human and the operators and robots. So if the robots get to know and can measure, for example, the average takt time of a person, or if a person is behaving in a certain way and they can adapt to the person and optimize the process, this is really something we're also looking at with sensor fusion. We're using radars, we're using 3D cameras, and we are passing that through deep learning to understand certain behavioral aspects. And that can, in a simulation environment, be also utilized on the design phase, where you're designing a cobot station and you're putting the human in the loop there.
Yeah, you just touched on collaborative robots, and I've been excited to ask you more about robotic safety. But I think unless you're deeply in the robotics world, I don't think people have really fully picked up the importance of this transformation to collaborative robotics, or even what collaborative robots in an industrial or logistics or services space are. So maybe start by helping define what collaborative robots are and illuminate more the transformation that's enabled.
Yeah. I think cobots has been kind of a fluid definition, but I think right now it's pretty static. I mean, the industrial robots are characterized by being very robust and fast, okay? Because ultimately they were there to maximize productivity and output, and because of that, they had to be in cages, okay? At the same time, they were, probably because they were grown in certain industries, they were really complex engineering machines, okay? I mean, you really, the use and it was complex, the design of the process was complex. So what cobots tried to address was somehow the two things. They are bringing robots that are inherently safe, meaning that you don't need any more defenses. Of course, that comes sometimes at the expense of performance, but in many occasions, there's still a benefit. So you can have now robots closer to the people, and that is really triggering a totally different thinking of the workflow. That's the most important consequence. You don't need to separate robots and people anymore, and that together is boosting the productivity of the solutions we can have, because it's a different thinking that where we can really optimize, because we don't have that physical separation. But then comes the second part, which is the ease of use, the interfaces, the intuitive wizards, so we can make those robots also available for wider industries, SMEs, and still I'm in industry, but at the same time, the next step is to put them in retail, or the robots we have in China now in restaurants, okay? I mean, they have to be easy. You're not gonna have two maintenance engineers of robotics in a restaurant in case it has to be easy to operate, it has to be easy to troubleshoot, it has to be friendly. So cobots are this new type of robots that are safe, light, and easy to use, and they enable different workflow thinking on the industry, and they are expanding robotics into more human environments in services.
Yeah, I saw firsthand the transformation when you can design a robotic system where the human can help, right? Can get involved and correct something. I want to talk a bit about sensors. I mean, I alluded to my barcode work, and I did get the chance to work with the first kind of digital CMOS sensors, which were 256 pixels by 256 pixels, grayscale, super noisy. And now we have these phones with 20 megapixel or better, incredible cameras. And obviously that kind of sensor improvement helps to make all these systems. I'm curious what sensor advances you're most excited about these days.
Of course, first and foremost, any vision-related capability. Because as I said, seeing the world enables understanding the world. This is coming from a human perspective, how we are mostly designing, and that's why probably we can better design things based on vision than anything else because of our own nature, you know. And so, as I said, if robots can see, okay, in the end, I mean, robots see is an abstraction because robots will see bytes, will feel bytes, but then they can process that. They can really start to have a semantic understanding of the world. This will enable, even with old technologies, to take super smart decisions that were not possible. I put the example of the AMR deciding which path to choose depending on if a pallet is static or if a forklift has a driver and can run or not. But I can put you other examples where this decision making of the robot based on the fact that I know if something is here and it is this and it has these properties, or is that and it has different properties, just with all logic can trigger a new level of performance of the robot. So for me, everything related to machine vision and machine vision applied to mobility as well, as I said, these are two fundamental. Then there, of course, when you go in the area more of the assembly, for example, or robot processes, all the interfaces for force sensor are becoming very important. And especially now that we have reinforced learning, if you can have the force sensing in the loop, for example, for pegging hole problems, for a fine assembly, for polishing, that is giving you a new dimension also to solve these more problems that require a lot of accuracy in the process.
For the last few questions here, I want to pivot a little bit more to giving our audience a perspective of where you might see things going. I was recently asked to for an article to say where I thought maybe there was excessive hype, and I kind of pointed to humanoid cobots. And then, a week later, Elon Musk announces that he's building humanoid cobots. But I'm curious, how do you think about the evolution of this kind of very general purpose humanoid robotic capability?
Well, I mean, of course, that's the moonshot, but we have our vision where we want to take robotics, and somehow that's part of it. 2 years ago, when we opened in Houston at the Texas Medical Center our incubator for robotics in healthcare, we unveiled our concept robot of mobile youve, which was a collaborative dual-arm robot on a mobile platform. Okay, as a preview of the work we're doing to bring to the market mobile manipulators. Okay, so robots, one arm or two arms in a corpse. Built on a mobile platform. Now in Houston, a couple of weeks, we just received the second version of that concept robot. And we can say that we are working to develop. Now we have the acquisition of ASTI Mobile Robotics, so we have even more competence on the mobile platform part. But how that will scale, we are very, very down to earth in the sense that we are looking at real use cases where the need for a mobile manipulator makes the return on automation better. And I'll put you a very concrete example. Low batch automation. And you can take a laboratory in a hospital. They never stop. They run 24/7. But the different type of tasks they do during the year, they change a lot. They have a batch of work that a robot could do in 1 hour. They could pick and place, load the machine, but then the robot is finished. What are you going to do with that robot 23 hours? Because the next thing they have to do is a different process in the lab. So are you going to put another lab in that other workstation and have the robot working another 1 hour there? That will never pay back. You better have a couple of robotic peers in the lab on wheels, and the lab manager has a schedule and say, hey guys, from 8 to 10, you work in that workstation, you work on that there. When you're done, there's a queue that's going to dynamically changing. You're sent to workstation number 3. There you need to load the centrifuge and so on. So it could be a lab hospital, could be any other, an SME where you have low batches that would not pay off for a robot standing still 80% of the time. But if that robot can do always something different because it can move among workstation, that is a very important use case. Then what are the skills? Going back to the beginning, what robot skills you need for that? At the beginning, it's mostly going to be about machine tending and material handling. So we're really focused on developing mobile manipulators that have, it's quite a broad capability, but very much focused on certain processes and certain applications.
We've talked about a lot of a diverse array of where robotics can be deployed, from manufacturing, e-commerce, logistics, healthcare. Where do you see the most promise from an emerging sector standpoint for robotics?
I think everything is telling us that logistics and e-commerce is still by very far, the largest market in the next 5, 6, 7 years. Because, I mean, there are companies pioneering the adoption of robots in certain applications, but the waterfall is really yet to come. Okay, we were talking about all these order picking applications. Yeah, it's getting to a mature state, but the mainstream deployment has not happened yet, and that is huge. Okay, only 5% of the warehouses in the world are automated. Only 5%. So all the reports, all the discussions in the community are pointing at that direction. Then the second biggest growth arena, but that's more of a mid-long-term development, is healthcare. And that's going to be driven by a perfect storm being built there, which is the talent shortage, the increase of cost, and the increase of complexity as we have more treatments and personalized treatment. But that sector is very has big inertia. It's going to take a lot of time, but the need there is so astonishing that it will happen eventually. Okay, and then of course we see that adoption in retail driven by the e-commerce is happening, and that because that barrier now is very blurry. I mean, what is retail? What is e-commerce? I mean, so we see robots in supermarkets just because they are offering online drive-through pickup. Okay, we see robots in a fashion store because you can buy online and pick up on store makeups. You can have in Korea, we have some robots that the cosmetic company has built a machine where you go and AI would scan your face. It would recommend you some colors of makeup. You would choose, and our Yumi robot would prepare a customized makeup for you. So customization is also pushing robotics into consumer segments quite a lot. And still manufacturing, of course, there's a big expansion in manufacturing. And the big thing here is how we reach small and medium enterprises to benefit from robotics. That's everyone's challenge in the industry as well.
And how do you think about when do we have robots in our homes? When are the robots helping us day to day?
Wow, that's big. I think there has to be innovation. There has to be still a lot of innovation and the maturity of the technology. We said on this, ultimate autonomy. But I foresee that there will have to be also some innovation in the business model, because no matter how costs go down, I think an individual, average family probably will not be able to spend some tens of thousands of dollars into a robot. But if you look now, for example, in the market, these robotic dogs. There are two very different approaches. There is an American company who's selling that at $70,000, and there is a Chinese company which is selling it at $1,700, but without software. So they are expecting an open source community to build applications. I don't know what's the right model. I really don't have but I do believe that the hardware cost will be still such a cost that there has to be a business model innovation for us to have robots at home.
What's the coolest thing you've seen lately that you can share?
What's the cost?
What's just the coolest advance you've seen lately that you can share?
Wow, I think I brought a lot of examples already. I don't know if I'm missing some. This Korean example of the makeup was very cool because again it was AI for something you would never think about. But I think where we're really betting double down, from ABB is in the hybridization of stationary robots and mobile robots. I think we can do fantastic things, and thinking about total different level of flexibility when you're going to have robots doing processes statically in a place, but then your whole design is connected by a flexible material handling flow, the AMRs, okay? Because this is not being explored, and I think we can have redeployable factories, we can have flexible factories, can produce totally different things, and the level of the innovation there would be really on the business side, because there are many industries where the capex needed, it takes so long to pay that you take a total different path. But if robots will be so flexible that you can evolve and scale and downscale and so on, that would be a total different picture. And the combination of mobile robotics and stationary robotics for us is the answer. And this is not only about the technology innovation, but it's really about the architecture innovation and the business model innovation. And this is where really we're really be investing more.
You've given an amazing kind of perspective on robotics and the evolution and where you think it's going. I think in my kind of final wrap-up question, I'll just offer you the opportunity to share anything maybe that you additionally wanted to share, and maybe something to kind of inspire and excite our audience about the future of robotics.
Yeah, I think, as I said, robotics, fortunately, it has the ability to take any technology development and apply it. And we are in an exciting moment. Acceleration in technology is all over and faster as ever. So robots will have the best batteries to move better and longer. We'll have the best cameras and sensing and AI to understand the world. We'll have the best CPUs to be able to connect to the cloud. And this connectivity will boost the collective intelligence of robots. So the vision of these robot skills being hosted in a big cloud where all the robots are learning and improving and can be deployed remotely, so that we lower the cost of ownership, we lower the investment. This is really the vision we see for robotics. A more intelligent and flexible robot that has a collective intelligence through robot skills that can really scale and bring robotics to benefit many, many more industries and people that it has been in at least my last 23 years.
Amazing. Hey, thank you so much for taking the time. Really enjoyed the opportunity to work together at Amazon, and hope to continue working together to help your AI needs. So yeah, thank you again.
Thanks a lot, Brad. It's been a pleasure. Thanks a lot for inviting me.